Okay, so again, I'm looking at the first derivative graph, and I'm wanting to graph the function and show concavity. So this is a way of saying do everything. Find the local mins and maxes, find the local mins, local maxes, and then find where it's concave up, concave down, and the points of inflection. All right, so let's go find the local mins and maxes first. And since I got the first derivative right in front of me, I'm going to use the first derivative test. So I'm looking at x equal -2 because that is a critical number. So at x equal -2, y prime changes from positive to negative. So therefore I know that f of -2 must be a local max. And now I'm looking at x equal 2, and I see that y prime changes from negative to positive, so I get the conclusion that f of 2 must be a local minimum. All right, so I'm going to get just a quick sketch of that because I know nothing about different y values of this. So I've got a max where the slope of the tangent line is 0 at -2, and I've got a min where the slope of the tangent line is 0 at 2. All right, so now I've got to find out when it's concave up and concave down. So I'm going to be looking at, and let me just go through and just look at where the derivative is decreasing. So the derivative graph is decreasing, so that means the second derivative is less than 0 before 0. So that means the graph is concave down all the way to 0. And then I see that the derivative graph is increasing, so the second derivative graph must be concave up. Even though it's a cusp here on the second derivative, it doesn't necessarily mean that it's any point of inflection or anything different is happening here. So it could be kind of vertical for a second and then coming back up. So just not vertical, but just, changing places. So the derivative is changing graph. So the point of inflection would be at x equals 0, where the changing concavity, and that's a graph of the f of x. All right, so this one does have asymptotes. So let's see what's happening here. So this is the graph of f prime again. Always look and see, make sure you know what you're looking at. So I want to graph the function. Okay, so let's look and see where the derivative equals 0 first. So the derivative equals 0, those nice kind of critical numbers happening at -2 and at 4. The derivative not existing happening at 0 and at 6. So these would be the cusps, the corners, the vertical tangents. These are going to be the different kind of looking ones. These will be like bottom of a parabola, top of a parabola, right? So that's what we're expecting. All right, so let's get using our first derivative test. So at x equal -2, y prime changes from positive to negative, so therefore f of -2 must be a local max. And let's see what's happening at 0. So at x equals 0, the derivative is not changing sign. It's negative, so nothing has happened. So I'm not going to summarize that one. How about at 4? At x equals 4, y prime changes from negative to positive, so therefore I get that f of 4 must be a local min. So this one is a local max, slope is 0, so nice thing like graph like this. This is with local max, local min, slope is 0, so bottom of a parabola. All right, now let's look at x equals 6. This is where the derivative doesn't exist, so I'm expecting a cusp, a vertical tangent, one of those graphs where the derivative doesn't exist. So at x equals 6, I see that y prime changes from positive to negative. So therefore, f of 6 must be a local max. Because it's changing direction, so it's got to be a cuspy thing or a cornery thing. We'll get that from the concavity. All right, so let's put these pieces of information together. So here I have -2 maximum. I have 4 At 0, the derivative doesn't exist, so something bad's happening there. So I'm just going to put like a vertical tangent thing happening. And then at 4, I've got a local minimum, bottom of a parabola. And then at 6, I've got a max, and I'm going to make a cornery thing. All right, so I'm just going to put it in a different color just to kind of make sure I'm putting it together. So I've got this, 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 this. Okay, so that's what, oops, make sure that's more of a max there. Okay, so now I get to go put together with the concavity. So because I see, so let me get a different color here. So the derivative is decreasing between negative infinity and 0, so that must mean the function must be concave down. So the function is concave down, and where else is the function decreasing? It is not. That's it. So the f of x will be concave up, where the function is increasing, so that's going to be 0 to 6, and then 6 to infinity. Okay, so concave down, so I'm going to do black to enhance the graph, concave down all the way to 0. So I'm going to make that a little higher, make it concave down, so something like that. And then it's concave up, derivative doesn't exist, so I'll make a vertical tangent there. And then it's going to be concave up, and then concave up. So I've enhanced it so that you can see that it's a cuspy thing right there at x equals 6 where the derivative doesn't exist.